Hi sir, myself T. Kaushik Reddy from GSCB of roll number 70. My concept video topic is delta star transformation or delta to star transformation. So here are the formulas for the conversion of delta to star transformation, resistance conversion formula. So there will be three resistance. One is R1, R2, and R3, and there will be 2 points in which they have each resistance in between them. So delta transformation formula R1 is equal to RA plus RB plus RB RC in plus RA RC by RC. R2 is equal to RA RB plus RB RC plus RA RC by RB. R3 is equal to RARB plus RBRC plus RARC by RA. If RA, RB, and RC and R star are all are equal, then R delta is equal to 3R star. So star conversion. RA is equal to R1, R2 by R1 plus R2 plus R3. RB is equal to R1, R3 by R1 plus R2 plus R3. RC is equal to R2, R3 by R1 plus R2 plus R3. If both or if three resistance and R delta are equal, then we'll get R star is equal to R delta by R3. Now delta to star resistance conversion formula. R1 is equal to RB/RC by RA plus RB plus RC. R2 is equal to RA/RC by RA plus RB plus RC. R3 is equal to RA/RB by RA plus RB plus RC. So delta star transformation. The replacement of delta or mesh by equivalent star connection is known as delta star transformation. Here, delta star transformation is nothing but the replacement of delta or mesh by equivalent star resistance or connection is known as delta star transformation. The two connections are equivalent or identical. Identical here means are same to each other. If the impedance is measured between any pair of lines, that means the value of impedance will be the part of it. If it is measured between any pair of lines, irrespective of whether the delta is connected between the lines or its equivalent to star is connected between the lines. So delta and star connected resistors. So here are three resistors between 3 points ABC, R1, R2, R3 between each. Here on the left side is delta resistance, and on the right one is star resistance. So here is a derivation for the formulas. So consider a delta systems that's three corner points are A, B, and C shown in the figure. Electrical resistance of the branch between the points A and B, B and C and A. So the resistance between A and B is R1, and between B and C is R2, and between C and A is R3 respectively. The resistance between the points A and B will be RAB is equal to R1 by R2 plus R3 is equal to R1 into R2 plus R3 by R1 plus R2 plus R3. Now, one star system is connected to these points A, B, and C as shown in the figure. Three arms RA, RB, and RC of the star system are connected with A, B, and C respectively. Now, if we measure the distance value between points A and B, we'll get RAB is equal to RA plus RB. So this is the derivation for delta star system that have three corners points ABC, and in between them there is three resistance R1, R2, R3. Between AB is R1, between BC is R2, between CA is R3 respectively. So now one star system is connected to these points ABC. So here the formula is RAB is equal to RA plus RB. Here are the different conditions for the formulas. Since the two systems are identical, resistance measured between terminals A and B in both systems must be equal. So RA plus RB is equal to R1 into R2 plus R3 by R1 plus R2 plus R3. Equation 1. If the two systems are identical, resistance measured between terminals A and B in both systems, then RA plus RB is equal to R1 into R2 plus R3 by R1 plus R2 plus R3. Equation 1. Similarly, resistance between points B and C being equal in the two systems, then RB plus RC is equal to R2 into R1 plus R3 or R2 into R3 plus R1 by R1 plus R2 plus R3. If the resistance between points B and C be equal in the two systems, then this is a formula. RB plus RC is equal to R2 into R3 plus R1 by R1 plus R2 plus R3. And resistance between points C and A being identical or equal in the two systems is RC plus RA is equal to R3 into R1 plus R2 by R1 plus R2 plus R3. In the resistance between point C and B being equal is in the two systems, RC plus RA is equal to R3 into R1 plus R2 by R1 plus R2 plus R3. Adding three equations, 1, 2, 3, we get 2 into RA plus RB plus RC is equal to 2 into R1 R2 plus R2 plus R2 R3 plus R3 R1 by R1 plus R2 plus R3. On further solving, we will get RA plus RB plus RC is equal to R1 R2 plus R2 R3 plus R3 R1 by R1 plus R2 plus R3. Here 2 gets cancelled on the either side. If we add the three equations, we got RA plus RB plus RC is equal to R1 R2 plus R2 R3 plus R3 R1 by R1 plus R2 plus R3. Now what if we subtract the three equations from equation 4? Nothing but the above the equation which you got by adding the three equations is fourth equation. By subtracting the three equations with the fourth equation, we'll get RA is equal to R3 R1 by R1 plus R2 plus R3 equation 5, and RB is equal to R1 R2 by R1 plus R2 plus R3 equation 6, and RC is equal to R2 R3 by R1 plus R2 plus R3. So the relation of delta star transformation can be expressed as follows. These are the following ways where the delta star transformations can be expressed or can be followed. The equivalent star resistance connected to a given terminal is equal to the product of the two delta resistance connected to the same terminal divided by the sum of the delta connected resistance. The relation for delta transformation is nothing but the equivalent star resistance connected to a given terminal is equal to the sum or the product, not sum, product of the two delta resistance connected to the same terminal divided by the sum of the delta connected resistance. If the delta connected system has same resistance R at its three sides, then equivalent star resistance R will be R is equal to a capital R into capital R by capital R plus R. Then we'll get R squared by 3R. If we cancel RR, we'll get R by 3. Delta to star transformation equations. So these are the equations for the conversion of delta to star transformation. So we'll get P is equal to AB by A plus B plus C, Q is equal to AC by A plus B plus C, R is equal to BC by A plus B plus C. If the three resistors in the delta network are all in the value, then the resultant resistors in the equivalent star network will be equal to 1/3 the value of the delta resistors. This gives each resistive branch in the star network a value of R star is equal to 1/3 into R delta, which is the same as saying R delta by 3. So here is the first example for the given topic, delta star transformation. Convert the following delta resistor network into an equivalent star network. So Q is equal to AC by A plus B plus C is the formula. So 20 into 8 by 130 is equal to 12.31 ohms. The next P is equal to AB by A plus B plus C is equal to 20 into 30 by 130. We'll get 4.61 ohms. Next R is equal to BC by A plus B plus C. We'll get 30 into 8 by 130 is equal to 18.46. So the first question is nothing but the conversion of delta star resistive into an equivalent star network. We have three formulas. We have to substitute the values and we'll get Q is equal to 12.31 ohms and P is equal to 4.61 ohms and R is equal to 18.46 ohms. So example 2 for the delta star transformation is, let us calculate the resistance of star network which are equivalent to the delta network shown in the following figure. So we have 3 points ABC and we have R1 with B. We have three resistance where R1 is in between A and C and R2 is in between A and B and R3 is in between B and C. R1 is 10 ohms, R2 is 60 ohms, R3 is 30 ohms. Here nothing but we have to convert delta to star transformation. given we got R1 is equal to 10 ohms and R2 is equal to 6 ohms and R3 is equal to 30 ohms. So we know the following relations, nothing but formulas of resistance of network, star network in terms of resistance of delta network. So Ra is equal to R2 by R1 plus R2 plus R3. Rb is equal to R2 R3 by R1 plus R2 plus R3. Rc is equal to R3 R1 by R1 plus R2 plus R3. These are the T formulas. We have to substitute the values given and we'll get the Ra, Rb, Rc. If on substituting the values of R1, R2 and R3 in the above equations, we'll get Ra is equal to 10 into 60 by 10 plus 60 plus 30. We'll get 6 ohms. On dividing 600 by 100. Rb is equal to 60 into 30 by 10 plus 60 plus 30. We'll get 1800 by 100, nothing but 18 ohms. Next, Rc is equal to 30 into 10 by 10 plus 60 plus 30. We'll get is equal to the 300 by 100 is equal to 3 ohms. So we got the resistance of the star network as Ra is equal to 6 ohms and Rb is equal to 18 ohms and Rc is equal to 3 ohms, which are equivalent to the resistance of the given delta network. So this is the way how you convert delta to star transformation on applying the formula Ra is equal to R1 R2 by R1 plus R2 plus R3. Rb is equal to R2 plus R3, R2 R3 by R plus R2 plus R3. Rc is equal to R3 R by R1 plus R2 R3. R1 plus R2 plus R3. So on substituting the given R1 R2 R3 values, we'll get Ra is equal to 6 ohms and Rb is equal to 18 ohms and Rc is equal to 3 ohms. So the methods for reliability evaluation of a complex systems using delta star transformations have been developed by several authors. They give approximate results because the basis on which the transformation is derived is not correct. This transformation can be carried out under certain conditions. So notation. SI, sets of branches excluding the branches forming the delta connected to node I, Rij. Reliability of the component connected between nodes I and J. Q naught Ij, probability of open circuit failure of the component connected between nodes I and J. QSij, probability of short circuit failure of the component connected between nodes I and J. RT, system reliability. So these are the conditions for transformation. In delta star transformation, 3 independent conditions are to be imposed as there are 3 elements to be determined. So 2 assumptions we have in the given slide. First assumption is the component states are S dependent. The branches of one set out of sets S1, S2, S3 have flown into the corresponding nodes. So here is a diagram for the reliability diagram. Subsystem A input node, etc. Subsystem B and output node, etc. The reliability before and after the transformation is the same. A, between node 1 and nodes 2 and 3, when all 3 sets are present. B, between node 1 and 2 when S3 is null set. C, between node 1 and node 3 when S2 is a null set. Reference 1 to 3 do not satisfy condition 3a. Also, the expression derived for conversion in 1, 3 apply only when condition 2 is satisfied. If there is no restriction on the flow outside the delta, then 6 conditions are to be satisfied, and hence transformation will not be possible in delta. So, delta to star equivalent condition. This is the diagram on the right. R1 to R3 to R1 3, R1 to R1 2, 3, etc. So on. So third, two-state device network. Consider, for example, 3 components. Each component has 2 states, example, operating and failure of a system which reliability is R13, R12, R3T connected to form the delta configuration shown in figure 1 and 2. This configuration can be transformed into star equivalent with reliabilities R10, R2, R30. R20, R10, R30. Applying S independent even probability loss to series and parallel component results in 1 minus 3. So here are the 3 equations. So So solving 1 minus 3 for R10, R20, R30 results in the relations for delta star transformation. R10 is equal to O1, O2 or O3. R20 is equal to O3 by O2. R30 is equal to O3 by O1. O1 is equal to R12 plus R13, R32 minus R12, R32, R13. O2 is equal to R13 plus R12, R32 minus R12, R32, R13. O3 is equal to R12, R32 plus R12, R13 plus R32, R13 minus 2R1, R32, R13. Third, state device network. The delta to star equivalent of a network consisting of an three-state devices, for example, operating short circuit failure, open circuit failure, can be obtained in the same manner as two-state component case. The expression of leg equivalence for the open mode failure case are Q010 is equal to 1 minus x1 y1 by z1, Q020 is equal to 1 minus z1 by x1, Q030 is equal to 1 minus z1 by y1, x1 is equal to 1 minus Q012, Q013 minus Q023, Q013 plus Q012, Q013 and 23, etc. Similarly, the expression for the leg equivalence for the short circuits are given as follows. For the example, consider the bridge network shown in the figure. Let R1, R2, 3, R31 is equal to P, use 4 minus 6, then we have a formula of R10 is equal to 1 plus P minus P square whole square by 3 minus 2P. R20 is equal to R30 is equal to 3 minus 2P whole square 1 by 1 plus P minus P square. Equivalence and reliability of this bridge structure with the even space method yields the same expression for the system reliability. So this is the delta to star transformation. We have to use the formula delta to star is nothing but R A is equal to R1 R2 by R1 plus R2 plus R3, RB is equal to R2 R3 by R1 plus R2 plus R3, RC is equal to R3 R1 by R1 plus R2 plus R1 plus R2 plus R3. Yeah. So this is the whole concept video for BEE physics concept video of delta to star transformation. Thank you.